Hey guys, welcome to day 26. Today we're going to talk about fitting a line to data and making predictions with linear models. Okay, so a lot of times you'll hear this referred to as the line of best fit, all right, or maybe even what's called the trend line. Okay, and we're starting to use our lines now to start making predictions. So um, before we begin, let's talk a little bit about a scatter plot. A scatter plot is a graph that's used to determine whether there is a relationship between paired data. Scatter plots can show trends in the data. So first I'm going to put up here, this is just quadrant 1 in a coordinate plane. So this is quadrant 1, 2, 3, and 4. Okay, so I'm just going to show you quadrant 1, for example. That means your input values, your x are positive and your y's are also positive. Okay, with a positive correlation, if you start gathering data and you graph the ordered pairs, and they look maybe something like this, you put it on the graph, the ordered pairs from the data sample aren't necessarily going to make a straight line. Okay, but if you look at this, you can see there is definitely a positive correlation because it's going up. So as your input values, your x values increase, so are your y values. Okay, so that's a little bit different than a negative correlation. So with a negative correlation, okay, as your input values increase, your dependent, then your output values are going to decrease. Okay, so that's a negative correlation. And if you look at it, it almost looks like a negative slope. Okay, now if you had data values that just really had no pattern at all, and there's no correlation, they're all over the place like that, these are all data points, okay, that's no correlation. So positive, negative, and no correlation. Well, what we're going to focus on today is the line of best fit, or the trend line. And that's going to be a line that's going to be made, it's going to kind of go through all of the points and make kind of the best line. Okay, so some of the points might be above the line, some might be below the line. They're going to average all of the ordered pairs together and come up with a line of best fit. Okay, it works the same way with a negative correlation. Maybe it looks something like this. Okay, now it's quite an extensive formula to do this. Okay, so we actually are going to be using our Desmos graphing calculator to do the calculations. Okay, so the directions in today's notes show you how to use Desmos, okay, and we start out with an example. The example says the table shows the amount of time required to download a 100 megabyte file for the various internet speeds. Assuming the trend continues, how long would it take to download the 100 megabyte file if the internal speed is 75 kilobytes per second? So here we have internet speeds. Our input values are 35, 40, 45, 50, 55, and 60. And our output values, the time it takes to download, correspond right below. Okay, so an input of 35 gives us an output of 6.65, and these are minutes for a 100 megabyte file. So what our end question is saying, well, what happens if we have an input of 75? How long is it going to take? Okay, so the first thing we want to do is we want to use Desmos to make a scatter plot of the information. So let me pull up Desmos for you right here. Okay, so here we have Desmos. I'm going to just make it a little bit smaller to have it fit in the window for you. This can do this, or maybe I'll make this a little bit bigger. Let's see, here we go. Okay, I want you guys to see this. Okay, come on. It's not cooperating. Let's see. All right, I'm going to just, I was hoping I could make this one smaller. I think I just exited. It's not cooperating. All right, so let me go to the side here. All right. Nope, not cooperating. Maybe it's not doing it in tablet mode. Let's see if I can do it not in tablet mode. Yes, I want to exit tablet mode. Okay. Ah, that's what happens. I can't. All right, let me go back to my video. Okay, so here we have Desmos. Now what we're going to do in Desmos is we're going to start by adding a table. And how we're going to do that, you're going to click the plus button and it's going to say add a table. All right, if you noticed, you've got your x1 and your y1 values. So your x values include 35, and this is a vertical table instead of the one that's in the example, which is horizontal, but it works the same way. So we're going to add in 45, okay, and then we have the value 50, and then we have the value 55, and then we have the value 60. Okay, now we're going to enter the corresponding y values from the example. We've got 6.65, and we're going to be really careful to make sure we put them in accurately. 5.82, 5.17, okay, 4.65, and 4.23. Oops, let's do 4.23, and then we have 3.88. Okay, so the headers say X1 and Y1, okay, and then each one of these values is actually an ordered pair. Okay, so if I looked at the ordered pairs, okay, if I want to kind of scroll out a little bit, you can actually see them, okay, there they are, okay. Notice it kind of looks like they're going down a little bit, that maybe our line of best fit is going to have a negative slope, all right, but we're not really sure. So it maps them all on the graph, and you can zoom in and zoom out and see that. Okay, but what's going to be really important is this next line, okay? And in the notes in 26A, you'll see it actually, all the steps are spelled out. But this line says we're going to take our Y1 value, which is the Y value, okay? And then you're going to click in this, you're going to shift, and then you're going to do this tilde. The tilde key is right above the tab key. So instead of Y equals MX plus B, we're saying Y1 tilde, and then we have this AX1 plus B. Okay, now that's super important, and again, you're going to see that, okay, in the notes. Now notice, Desmos put a line through all those values, or really what's close to those values, okay? In this case, they're kind of really close, to being on the line. But it comes up with a line of best fit, all right? Notice we have our y-intercept, and we have our slope, okay? So if you look at it, the slope is actually down here in your A value. The A value, because we said y tilde AX, notice the coefficient before your X is the slope. And in this case, it's negative 0.1093. We're going to round to the nearest tenth, so the place right after the decimal. So we're going to say our A is negative 0.1, and our B is going to be 10.2. Okay, so that's super important. We're going to remember that information so that when we write it down, okay, we've got our A. All right, we said our A value is negative 0.1, and our B is equal to 10.3. All right, we then use those two values and we write the line of best fit. So we're going to come over here and we're going to say our Y, the equation for the line of best fit is Y is equal to negative 0.1 X plus 10.3. Okay, there's our equation. All right, so just so you know, on the Desmos calculator, this is what you typed on that second line after you entered the table, okay? Y1, then you have the tilde, AX1 plus B, okay? So right here where it says the tilde, for yours, you're going to click the tilde. Let's see if we can put a little note here. The tilde is click on the ABC button to get the tilde. All right, so you might have to play around with that a little bit to see how you can get that. But once you write the equation of the line, you just use your A value and your B value, and you write the equation of the line. Now, when you want to make a prediction, we're saying, well, what is the time to download if we have an input value of 75, okay? So here we have our 75. So we're just going to take the X value. We're going to let our X, or our input, be equal to 75. And we just plug it in to get our Y value. So Y is going to be equal to negative 0.1, and instead of X, we're going to put our 75 plus 10.3. Okay, we're going to use our order of operations at this point, and we're going to come up with that Y takes 2.8 minutes. Okay, so there's our answer. All right, so in the notes, we just go through this and we practice different problems. So in class, we entered this table in Desmos, and then we said Y1, and we said tilde AX1 plus B, and we found out, and you can try it right now. I suggest pausing the video and seeing what you get. Your A is 1.6, your B is equal to 2.3. That means your equation is y is equal to 1.6x plus 2.3. All right, so again, number 2, a lot of this is just practicing using Desmos. There's your second example. All right, pause the video here and try that in Desmos. When you do that, your A value ends up being negative 4.4. Your B value ends up being 14.7. That means that if you're modeling y as a function of x, your y value would be equal to your negative 4.4x plus 14.7. Okay, and again, we just go through a series of examples. Here, we're looking at kites. It appears that the input value for 1 month, a store records the price of kites in dollars and the number of kites sold at each price. The data is shown in the table. So we're going to use the Desmos calculator to make a scatter plot, and then we're going to find the equation of trend line. That's the finding the line of best fit. And then we're going to make a prediction of how many $40 kites the store would sell. So we put these values into Desmos. We have our x1 and our y1. And our equation of trend line, if we do it correctly, our A value after we round it is negative 0.5, and our B is going to be 28.5. So the equation would be y is equal to negative 0.5x plus 28.5. All right, now here we're going to use that equation to make a prediction. We want to know how many kites we'd sell at $40. Okay, so as you can see, as the price is increasing, the quantity that we sell is decreasing. So the more expensive the kite gets, the less number of people buy it. Okay, so a $40 kite, we would just notice 40 is our input, so we're going to let x be 40, and we're going to plug it in. Y is equal to negative 0.5 times 40 plus 28.5. Okay, so we've got a negative 20 plus 28.5, and we end up with 8.5 kites. Well, since we can't have half a kite, we're going to answer this as 8 kites. Okay, so that's kind of approximate, but we're using that line of best fit to make a prediction. Okay, so our next example, again, you can keep trying it, all right, using this data. Again, pause the video, put it into Desmos. This is your x, this is your y. Okay, if you do this correctly, your A is 0.4 and your B is negative 19.8. Your A is your slope, so your y is going to be equal to 0.4x, and your y-intercept is the B, so minus 19.8. So now this is a good example because if a man has a shoe size, so this one had to do with a height in shoe sizes. If a man has a shoe size of 10.5, what would be his predicted height? Well, notice the shoe size is actually the output. So we're going to take 10.5 and we're going to now solve for x. Okay, so we're going to use our knowledge of algebra. Okay, and we're going to solve for x. We do that by adding 19.8 to both sides. Okay, and when we do that, we get 30.3 is equal to 0.4x. Okay, and then we're going to divide both sides by 0.4. Works the same way with decimals. So then when we do that, our x is going to be equal to 75.75 inches. Okay, so we made a prediction. All right, let's try one more. All right, looking at number 5, the table below gives the number of hours spent studying for a science exam and the final grade. So if we studied 2 hours, we got a 77, 5, and 92. So we've got all these data values. We plug them into Desmos, and if you do it correctly, your A value should be about 6.1, and your B is 63.9. So the equation of the line of best fit is y is equal to 6.1x plus 63.9. Now we want to predict the exam grade, so we're predicting the y value for a student who studies 6 hours. We're going to let our x be equal to 6 and plug it in. y is going to be equal to 6.1 times 6 plus 63.9. Okay, so when we do that following order of operations, our y is going to be equal to 100.5 or 100%. Okay. All right, so that would be it. So I highly suggest practicing this as much as you can on Desmos. All right, so you'll do well on the test. Okay, bye-bye.